Today I'm going to go over 9.2, representing data. So we're going to be making some charts. The first type of chart that we're going to do is something called a dot plot. Okay, and it'll show the frequency on a number line. So we're going to create a number line. Looking at our data here, smallest number I see is 7 on up to, we got all the way up to 19. So we make our number line, including all the values that we see, and then you're going to place each of these numbers where they go. I'm going to cross them off as I go. So you have 7, we have 9, 12, and you'll do this through the whole table of values. Okay, so this should be what it looks like when you're done. We've got 1 on 7, 2 8s, 3 9s, 2 10s, 1 12, 5 14s, 3 15s, a 16, a set 18, and a 19. All right, so you guys go ahead and try the next one. So this is what that dot plot should look like. Okay, the next type of graph we're going to look at is a bar graph. Okay, and a bar graph compares categories of data. Bar graphs are used when the data is categorical. Okay, so we have different categories. We're going to put those categories on the horizontal axis here. Okay, and then vertically we want to go up to at least 35. So here we've got our different categories. Okay, so these are our types of music. Okay, and then here we need to go up to 35. So I'm just going to make this 40, cut that in half to get 20, make that 10, 15, something like that. And we'll just do our best to graph these bars. So when we graph it, so 13 is going to be about here. When we graph it, we'll represent it with a nice bar here. Okay, and then hip hop is at 35, so all the way up here. And you're gonna leave a gap in between the lines. Okay, because this isn't a continuous thing. Each bar should be distinct. So there's our bar graph. And I realized I'd written the wrong thing here, so 10, 20, 30 is what that should say. All right, so you go ahead and try the next one. So there's our bar graph for the different types of instruments. The next type of graph we're going to do is a histogram. Okay, histogram is going to be like a bar graph, but it's going to display numerical value that has been organized into equal intervals. So histograms are used when the data is continuous. We have numerical instead of categorical, and it's continuous rather than being discrete categories. So our first histogram we're going to graph, we have the frequency of presidents at different ages here. Author inauguration. So this one's already organized into areas anyway. Sometimes you may need to come up with what that looks like. Okay, so I've got 40, we'll go 45, 50, 55, 60, 65, and 70. So our first area, so this is going to be age. And this would be the number of presidents. First one is at 2. Okay, these ones, there will be no gap. 7, because the data is continuous. 13. Next is at 12. Next we're at 7. And finally at 3. Okay, so you go ahead and do the next one. So here's our histogram for the age of volunteers. In our next example, the table shows different temperatures of sick high school students that came into the nurse's office in a week. Determine whether the data should be shown in a bar graph or a histogram by determining whether the data is continuous or discrete. Then we'll make the appropriate graph. So this data is going to be continuous. So we're going to use a histogram. To do that, so I'm going to organize the data. And kind of looking at this, we've got a range from 98 to 101 or so. So for my groups, I'm going to go from 98 to 98.9, 99 to 99.9, 100 to 100.9, 101 to 101.9, and we don't have anybody of, oh, we do have one. So we'll do 102 to 102.9. And then we'll count how many are in each category. So for 98, we've got 1, 2, 3 of those. 99, 1, 2, 3 that fit in that range. 100s, 101s, and 1 left. And then we'll go ahead and make our histogram. So there is our graph. The next one, we've got the different categories and how many Olympic medals they have won. So this is going to be discrete, so we're going to be using a bar graph. So there's our bar graph with our different medal counts. Those are different ways that we can represent data.